This lesson is on polynomial division. It's important that you have your notebook for this because this is probably one of the most complicated things we've done so far. So it's kind of different from most anything that you've done. I want to make sure you have examples in your notes when we finish. So in polynomial division there's the simple kind, which is sort of what we have done before, and the more complicated, which most of you have not yet done. So let's look at a simple kind first. The simple kind, I'm dividing by one single thing. Sometimes it's a variable, sometimes it's a number. But you would get something like 6x squared plus 2x divided by x. In this case, I'm going to look and make sure, does the x go into every single term of that polynomial? And it does, so I divide the first one by x and get an x. I divide the second one by x and get a 2, and my answer is 6x plus 2. I think you're familiar with this sort of problem. Could also be dividing it by an integer or a number. So I could take 4x plus 8 and divide it by 2. Well, 2 does go into each of these terms, so I divide them both by 2, and I get an answer that's 2x plus 4. But if you look here, sometimes I'll get a situation where I have 4x plus 8 divided by x. X does not go into this second term, so I can't simplify the entire expression. I'd have to do something a little bit different. And we'll talk about that more later. So always pay attention to whether or not your item is going to go into every single term or not. So let's take a look at an example here. Now I have 5xy squared minus 12x cubed y to the fourth minus 6 divided by 3x. Looks very complicated, but the bottom line is all I need to know is, does 3x go into each of these terms? So I'm going to look at them all individually. I'll write the first term and put the 3x down here. The second term, put the 3x, and the third term, put the 3x, and see how I can simplify those. So it turns out, in this case, I share an x, but the 5 and the 3 are not going to simplify, and the y squared will stay. So I can cancel the x's, but take a look. I'm left with 5 over 3 and the y squared. In the second term, I have 12 divided by 3, so I get 4, and the x's will cancel to an x squared, and the y to the 4 stays the same. And in the third term, I can cancel with the 6 and the 3, but notice there's no x in my numerator, so I can't cancel the x's and it stays down here. So here's an example of the sort of expression you might get if you have some terms that are divisible and other terms that are not divisible. Okay? So that's about all we're going to talk about as far as the simple version. Let's talk about the complicated version, which is actually a lot like long division that you did back in the day. So let's look at a sample of regular arithmetic. 12 into 276. So first thing I would look at is I look at these numbers 24. Does 12 go into, 27. Does 12 go into 27? Yes. It goes 2 times. So I put a 2 up here. Then I multiply and get 24. I subtract and see what's left over, and it's a 3. Bring down the other number, I have 36. Go back. Does 12 go into 36? Yes, it goes 3 times, so I put a 3 here, multiply, put my 36, subtract, and I have no remainder. My remainder is 0. So I know that 12 times 23 does in fact equal 276. I'm hoping this flashes back to you from 3rd or 4th grade, because we're going to do the same thing now with polynomials in almost the exact same manner. So now we have x to the third minus x squared minus 6x divided by x plus 2. Not divided by x, divided by the entire quantity x plus 2. So I'm going to set it up just like in the olden days. X plus 2's out here, my polynomial's here in the house, and I'm going to start. Now I don't really care about the entire x plus 2. This is where it's a little bit different. All I look at is the x. How many times does x go into this first term? And in this case, if I was to divide this in, I would find that it goes x squared times, because x squared times x is x to the third. So I put my x squared up there. Now once I do that, I'm still going to now multiply x squared by each one of these two and put it in place. So I put an x squared times x, and I get x to the third. And I also put x squared times 2, and I get 2x squared. This is very similar to the regular division. I put my subtraction sign, draw a line, and I subtract. Okay? X squared minus x to the third minus x to the third is nothing. Make that go away. Okay? Whoops. Took away my negative sign here. But negative x squared minus 2x squared, this is where you're really going to have to pay attention to those negative signs. Negative 1 and negative 2 equals negative 3x squared. Okay? Then I come over and I, just like in regular division, I bring down the next term along with its sign. Okay? Now I come back over here and say, how many times would x go into negative 3x squared? And the answer is negative 3x. It's just one exponent down. So I put the negative 3x up here, and now I multiply it. Negative 3x squared, boop. Negative 3 times 2, negative 6x. And now I'm going to say negative 3x minus negative 3x, right? That's going to cancel and make a plus. I have no x squareds left. Negative 6 minus negative 6, which is like negative 6 plus 6. I have nothing left here. Now I had one more term that I added in over here. Do you see? Whenever something is left out of standard form, I put whatever is in it in its spot. Okay? It didn't matter in this case because I'm just bringing down 0, but I want you to get used to the fact that I must have a 3, 2, an x, and a number when I do my division. So there's no remainder, so the answer is simply x squared minus 3x. That's the answer to this problem. Okay? Let's do one more together. This is one of those things that you're probably just going to have to dive into and practice when the time comes to practice, because until you actually feel it, it's hard to tell what your problems are going to be. Okay, here's one. Negative y squared plus 2y to the third plus 25 divided by the quantity y minus 3. First thing you should notice is I have things out of order in standard form. So I would immediately change and put the 2y to the third first minus y squared. Notice there's no y term. It goes straight from y squared to the constant, to the numbers. So I put in 0 y's right here because I need to go 3, 2, y, and number. Okay? Now I come and I do the same process. How many times does y go into 2y to the third? And it goes in 2y to the second time. Now I multiply this and get my 2y to the third. And I also multiply 2y squared times negative 3 and get negative 6y squared. Subtract. Negative y minus minus, that's plus 6, is positive 5. So I have 5y squared. I bring down the 0y because that's the next term. And now I come back and say, how many times does y go into 5y squared? And it goes 5y times. Okay? Because 5y times y is 5y squared. It goes, let's see, and then 5y times negative 3 gives me negative 15y. Okay? I pay attention to that negative sign. Now I subtract, and this goes away. I have 0 minus negative 15, so I have positive 15y now. Come over, bring down my 25. Okay. Now, how many times does y go into 15y? 15 times. 15 times y is 15y. But 15 times negative 3 is negative 45. So I have 25 minus negative 45, 25 plus 45, and I get 70. Y cannot go into 70 because there's no y over here for it to go into. So we call that a remainder, just like we have a remainder in other division problems. So my answer is 2y squared, you can get from right here, plus 5y plus 15 with a remainder of 70. And then as a denominator, I'll put the original problem that we were dividing by. Okay? Sometimes you'll have a remainder, sometimes you won't have a remainder, and we'll talk more in class about what it means when you have a remainder. So this is the essence of long division with polynomials. What I want you to do right now is take a look here. I want you to pause this video, copy this problem down, and put it in your notebook. Do the problem out yourself. If you get stuck, go back and look over again, and I'm going to finish this problem up while you're paused, and we'll see if you got the right answer. Okay, so I did exactly the same process we were doing before. I said, how many times does x go into 2x to the third? And it turns out it's 2x to the second, one exponent smaller. I multiplied 2x to the third, I multiplied times 3 and got 6x squared. Subtract. This is the part you have to pay attention. Negative x minus 6. So negative 1 and 6 more in the negative is negative 7. Negative 7x squared. And then when I say how many times does x go into 7x squared, and it goes negative 7x times, right? I multiply times both, and I get over here negative 21x, 7 times 3. 7 minus negative 7. Negative 7 minus negative 7 is negative 7 plus 7, so that went away. Negative 20 minus negative 21, or negative 20 plus 21, is 1x. I brought down my 3. How many times does x go into x? 1 time. And I multiplied and got x plus 3, and I have a remainder of 0. This is a pretty complicated new thing, so I want you to make sure you understand. Please write down any questions that you have. Bring those to class tomorrow.